Okay, so then how is your code running? All right, it runs well, right? So then let me introduce another way of reporting estimation results. Okay, particularly using graph. Okay, here we have four uh, betas and one sigma square. Okay, so then particularly we are interested in the parameters in the in betas, right? Beta 1, 2, 3, and 4. Okay, so then I want to report the prior and posterior distribution for beta together. Why? Because I want to show that the results of my data analysis is heavily driven by the data rather than my prior. Okay, so then the way is just plot the prior and posterior distributions together. Okay, the command is prior posterior plot. Okay, so this is a function created by myself, and then I'm going to upload this file to the Blackboard. So just download it and just move it to your my library. Okay, so then the first one must be prior distribution, prior distribution, and then second input is posterior. Then my posterior distribution is in this example is, I would say, beta 2. Okay, so then beta 2 is where? Beta 2 is where? Colon, comma, beta 2 is where? So this is the this is storage for posterior samples, right? The first column of the MHM is beta 1. The second column is the beta 2, right? The second column. And the name is what? Beta 2. Then that's it. Okay. So let me ask you, do we have posterior distribution here? No, we don't have posterior distribution. Oh, sorry. Do we have prior distribution? No. It must be what? It must be the samples from prior distributions, right? And where is the samples for prior distributions? We have never generated prior samples from the beta 2 prior distribution. Where is the beta 2 prior distribution? Here, right? Its mean is what? Its mean is 0, and variance is what? Variance is 9, right? So then let's generate the beta 2 from its prior distribution. Its mean is what? Second value of beta 0 plus rand n, and how many samples? How many samples? n1, 1. Because we have n1 posterior samples, right? So then here we are generating n1 prior samples from beta 2's prior distribution, and its variance is what? 9. So that I would say SQRT B0 2,2 times, and then I think I need one more parenthesis here. Why this is 2? Because this is second value of the beta 0, and this is 2,2. So, or I would say this is second value of diagonal elements of B0. Why? Because the second value is what? This is the prior mean of beta 2. What if this is 3? This is prior mean of what? Beta 3. And this is prior mean of beta 1. So, right? So in this case 2. Of course, in this case, all betas have the same prior mean and variances. So whatever this is 1, 2, 3, it doesn't matter. But in general, they are not necessarily the same. So that's why I put 2 specifically, right? Okay, so then this is what? This is prior samples. And so this is prior samples. And this is posterior samples. the first input must be prior samples. The second input must be posterior samples. And this is the title, I would say. Okay? And then let me run this. That something wrong? Okay, let me check the function name. Plot. I'm sorry. Plot. Plot prior and posterior. Okay. Change folder. Yeah. Right here. Okay. So this is the output. Okay. It's very interesting. Why this supposed to be larger? I don't know why. Yeah. Yeah. I don't know why. Oh, oops. Okay, let me try this again. Why? Let me make it bigger. It doesn't respond. Why? Yeah. Maybe my computer is running slowly. I don't know. It doesn't matter. Okay. Again, here, let's take a look at this figure. Here, this black dashed line is what? Prior. This is my prior distribution. So I guess roughly the mean is 0, but it could be any value between -4 or -6 and 6, right? So but these areas are just small tails. So then again, according to my prior information, the beta could be between any values between -2 and 6 or -4 and 4, right? And this is my posterior distribution. But so this is updated, or I'll say Bayesian updated distribution for beta 2. Updated by what? Updated by the data or information in the data. According to the data, the beta must be around 2. And it should be, of course 2 is just an estimate. So this is not true value. So it must be uncertain. So it's uncertain, but its value must be roughly between 1.8 and 2.3, I guess. Here, let's calculate the credibility intervals. It should be between 0.8 and 2.4, right? Okay, with 95% probability, right? Okay, so then this is my prior information. So this is my estimation results without using data. But once we use the data, data is incorporated, then this must be the updated inference about the beta 2. So then this is my estimation result, right? So then that means that my prior didn't play very strong or important role in getting this my posterior result, right? So then this result is mostly driven by the data information rather than my prior information. So this results can be said to be objective rather than subjective, right? Okay. Here, so then let's see again. This function should be where? Should be in this folder, in this current folder, or it should be in your my library, right? So then I'm going to post this method function file in the Blackboard. Just move it to your my library. Otherwise, this will not run. Okay, and then let me run this again. Okay. Here, where is title? Okay, title is here. Beta 2. Yeah, it doesn't look very good, and it doesn't look quite professional, I would say. So then, one interesting way is to change it to a Greek rather than this alphabet. So then the way is slash and underbar. Okay, so then let me run this. Okay, still it doesn't look good, right? Why? Because this is still text, not a math expression. And to say that this is not a text, this is a mathematical expression, then we have to do something more. Here you have to put here this one and this one. Okay, now let me run this. Yes, can you see that? Better too. Looks much better. So right. Okay, and if you try to plot the prior and posterior distribution for, I would say, beta 3, so then this is just 3, 3,3 and MHM3, and of course the title must be 3, right? So then, yeah, you don't have to run whole code again. Just let me just here designate this area and press right button. You see that evaluate selection or F9, and click this. Then we have this another figure for beta 3. Okay, all right. So then, yeah, so it's very interesting, isn't it? All right. Okay, I think, yeah, we are done today. Again, please make sure that the next method assignment is due Tuesday. Okay, on Wednesday we are going to make a function for this skip sampling. Okay.